Okay, we're going to look at using inverses that we just learned in the last section to solve systems of equations. And so we'll start off with a little example. If you're going to solve 2 times x equals 14, of course you could divide by 2, or just as easily you could multiply by 1/2. And we're going to multiply by 1/2 on both sides. And we get, of course, 2x divided by 2 gives us x. Really we have 1 times x, right? And 1's the identity for multiplication. So we have 14 divided by 2 and x equals 7. So notice how we multiplied both sides by 1/2. So that's similar to what we're going to do with inverses with matrices. So the first thing we have to look at is we have a system of 2 equations, 4x plus 3y equals a -4, and then we have 3x minus y is equal to -3. So what we're going to think about doing is we're going to put this entire matrix in, and we're going to put the second matrix in on the second line here, and we're going to do something unique right here. We're going to put our variables x and y right here, and we're just going to set up our matrix. We have 4 and 3, and that equals a -4. So our solution is going to be over here on the right hand side. So it looks very similar to the way it's set up when we first start. And then down at the bottom we're going to have 3, a -1, and all that equals to -3. So let's see what would happen if we multiplied this matrix by our xy matrix. Well, you'd have 4x plus 3 times y, which is exactly what we have. And then if we do the second column of this, or excuse me, the second row of this, we would have 3 times x plus -1 times y. We would end up coming back to that green equation that we have from above. So if we can figure out how to use our inverses, then we should be able to solve this one. So what's the first step in finding the inverse? Well, we have to find the determinant first, right? So what's the determinant of our matrix? We have 4 times the -1, which equals -4, minus 3 times 3 is 9. So that would equal that quantity -13. So that's the value of the determinant of this matrix. And then to find the inverse, let's switch colors. So to find the inverse, we're going to simply multiply the scalar factor, and whoops. And what do we do with our quantities? Well, we switch A and D, the first element and the last element, so we have a -1 and a 4. And then the other 2 elements, B and C, we make it the opposite quantity, so -3, -3. So our inverse function has some fractions in it. -1/13 times a -1 is a positive 1/13, and -1/13 times a -3 gives us positive 3/13. And we have the same quantity here. And now we finally have a -4/13. So remember the special property that says if we multiply the inverse matrix times itself, what we get is the identity matrix 1, 0, 0, 1. So that's exactly what we're going to be doing right here. So if we think of this as A inverse, and we multiply it by A, we get 1, 0, 0, 1. And if we multiply that by our x and our y, it's going to simply give us x, y equals, and our quantity over here. Well, just like in the example above, when we multiply by a 1/2 and a 1/2, well, we're also going to multiply the inverse right here to our solution. And it does matter what order you multiply this in, right? Because this is a 2 by 2 and this is a 2 by 1. If you tried to do it the opposite, you wouldn't get the correct solution. So anyway, let's go ahead and write down what we need to on this problem. So our inverse, which is that one that has all the fractions in it. Let me just move this up a little bit. So this is going to be our A inverse right here. Is 1/13 and 3/13 and 3/13 again and negative 4/13. And our A is still 4, 3, 3, negative 1. Repeating our A inverse, we have 3/13 and 3/13 again, and a negative 4/13 here. So if we multiply this, which we'll do part of this, I guess. Normally we would probably just use a calculator on a problem like this, but let's just figure out what that first solution would be. We have, let me erase this over here so we can have some scratch room. And we'll do it in, we'll do this in green, I suppose. So we have negative 4/13 plus a negative 9/13. And what does that equal to? We have negative 13 over 13, and that equals a negative 1. So that's our answer to that one. And now we'll do the second column, excuse me, the second row by this first column, and we get something similar. We have negative 4/13 plus positive 12/13. Negative 4 and positive 12, so that gives us quantity 8/13. And it looks like maybe I made a mistake somewhere. Let me check this real quick. Oh, sure did. I knew that didn't look right. Let's erase this last one here. I can't read my own writing here. This is actually 3/13. So that makes this negative 12/13. Negative 12/13 added to positive 12/13 gives us 0. So our y quantity is equal to 0. Okay. Well, let's speed this up a little bit. Let me highlight what we really have done here. To solve this equation, as long as you have it set up like this here, really what you're doing is to solve for x and y. Let me write it in maybe a color we haven't used yet. Okay. I'll just do it in green. So what we're doing to solve for x, y, we're multiplying A inverse times the answer matrix, which is this 2 by 1. So we have two elements over here. So let's just pull this up, and let's do it with the calculator. I'll show you how to do this pretty quickly. So, in fact, maybe we would be better suited if we labeled our matrix, and if we called this B right here. And so we'll call this first matrix A, which is 4, 3, 3, negative 1. And then, let's see. So we're just multiplying A inverse times our C matrix. Oh, actually B, I'm sorry. We're going to call it B. Okay. So let's put this in the calculator and see if we get the same result. So let me clear my memory out here. Okay. So remember, all we're looking at is we're going to put in the first matrix in A, which is a 2 by 2, so second matrix, and we'll edit that A, and we'll put a 2 by 2 on there. And we have 4, 3, 3, negative 1. That's just the x and y coordinates for those two equations that we've been given. 4x plus 3y and 3x minus y. And then into matrix B we're going to put in a 2 by 1, which is the answers, which is in this situation the negative 4 and negative 3 in our given equations. So let's edit that. We have 2 rows by 1 column, and negative 4, negative 4 and negative 3. And now we're just simply going to do this portion right here. Whoops. We're going to multiply it A inverse times B, and we should get the same answer that we got. So let's try that. Second matrix, A, and then press the inverse button right here, times matrix B, that 2 by 1 that we put in there, and we get negative 1 and 0. So that negative 1 is our x solution, and our y equals 0 is the y. So hopefully this helps you, and you're comfortable using the calculator solving these by using inverse matrices.